those movies and like the action chase scene where like the car goes flying off a cliff? Like, you know, that reminds me a lot about like angle projectile motion.
Kyle Cheng, science man. Science rules. Radical. Newton's second law, F equals ma. Kyle Cheng, science man. AP Physics. Whoa, AP Physics.
That was a pretty bad dream. Whew, almost thought I died there. Anyway, what was I saying? Right, angled projectile motion is pretty interesting. Here, let me show you. Alright, so we all know that it's wintertime, right? And what do people love to do in their wintertime? Well, they love to throw snowballs, of course. Our friend here is going to take a snowball and then apply an outside force to it to accelerate that snowball until he lets go and it becomes constant velocity. And then gravity takes over and it decelerates and accelerates until it finally hits its target. And boom! Ah! Oh. Ow. Man, that really hurt. But wait, that was a perfect example of angled projectile motion. Rewind that footage. Ow, that hurt to look at. But you know what? Let's put that into animation form, shall we? We know that objects launched at complementary angles have the exact same range. At 60 degrees, the ball has a lot of vertical velocity, but not as much horizontal velocity, so its airtime is far greater than the ball launched at, say, 30 degrees, which has far less vertical velocity, but more horizontal velocity, so it travels faster horizontally with less airtime. Wow, ain't that neat? We just learned that things launched at angles that add up to 90 degrees actually land in the same place, just with different horizontal velocities and air times. We know that the thing launched at 60 degrees has a lot more air time than the one launched at 30 degrees. However, the object launched at 30 degrees has a lot more horizontal velocity than the one launched at 60. This eventually leads to them ending up and landing in the same place. Now, with all that work said and done, I believe that I deserve a break. So I'm gonna go take a well-deserved bike ride, and I'll see you guys there.
Let's do this.
Nope, y'all don't pay me enough for this. That is one steep drop. You know, I think I prefer to live for today. Whew. Man, that was a close one. I almost rode my bike off a cliff. Well, anyways, why don't we go and check out that animation?
We know that changing the angle of launch results in a change in the horizontal range, but we can also change this range with more speed. A faster x velocity means more horizontal distance, and since x velocity is constant in the air, the more speed, the merrier.
So, what have we learned during this little adventure? Well, now we know that in angled projectile motion, the projectile has both x and y velocities, with x velocities being constant and y velocities accelerating because of a little known thing called, and remember this, gravity. Anyways, we also learned that you can change the distance that the object travels by changing the angle at which it's launched. And side note, if it's launched at a complementary angle for example, 60 degrees and 30 degrees, we know that if they're given the same speed at launch, they will end up in the same place. Also, you can change the distance that the object achieves during launch by adjusting the speed. If you make it go faster, the object will travel farther. If you make it go slower, the object might not travel as far, and its airtime will be reduced. Anyways, that has been another episode of Kyle Cheng, the Science Man. Thank you for watching, and I hope you enjoyed.
AP Physics. F equals MA. Radical. Science rules. Kyle Cheng, the Science Man.